Hello students, I welcome you all on my YouTube channel. In this video, we will be discussing rule number 3 and 4. Okay, we are going to take problems on rule 3 and 4, right? So as we saw in the last videos, if curly m by curly y is not equal to curly n by curly x, then equations are known as non-exact equation. And if we want to find out integrating factor solution of these sort of equations, then we need to find out integrating factor, right? So see here, if they are not equal, then their difference is not equal to 0, right? Their difference is not equal to 0. If we divide this difference by n, if this comes out equal to function of x alone, say f of x, then exponential f of x dx serves as integrating factor for the given differential equation. Okay, this was rule number 3. Okay, and 4 says if curly n by curly x minus curly m by curly y upon m is function of y alone, then integrating factor is equal to exponential fy dy, right? So we are going to take some problems on these rules, right? So firstly, solve y4 plus 2y dx plus x cube plus 2y4 minus 4x dy equal to 0. Okay, so see what is m here. M is equal to y4 plus 2y, and n is equal to x y cube plus 2y power 4 minus 4x. Fine. So let us see whether or not this equation is exact. So in order to find out whether or not this is exact, we need to find out derivatives. Curly m by curly y, which is equal to, so see, this is your y, this is your m. Okay, so differentiate this with respect to y, we will be getting 4y cube plus 2y, and also curly n by curly x is equal to, here y would be treated as constant because we are differentiating with respect to x, so differentiation of x would be y cube plus differentiation of this would be 0, and 4x का differentiation हो जाएगा -4, right? So now you see curly m by curly y is not equal to curly n by curly x, therefore given equation is not exact. So now question is how to find out its solution, right? So we have seen number of methods in order to find integrating factor. Because this is not exact, now we want to make it exact, and the integrating factor is the only solution. Okay, only way to find out its solution. Integrating factor is only the way to find out its solution, right? Because when we multiply this equation by integrating factor, then this equation will become exact. After it become exact, we can directly find out its solution. its solution would be given by curly integration m dx plus all those terms of n which do not contain x, integration of that equal to constant of integration. So see, let us try to see rule by rule whether or not which rule it would be obeying. Okay, so which is the best alternative to find out the integrating factor of this equation. Okay, first rule is if given a differential equation is homogeneous, then 1 upon mx plus ny is the integrating factor. So see here, is equation homogeneous or not? Obviously it is not homogeneous because degree of y is 4 and degree of this is 1, therefore this is not homogeneous function. Okay, thus we can say first rule cannot be, we cannot apply first rule here. Okay, now secondly, you see in second case, if equation is in this form, okay, y dx y fxy plus dx plus x g y dy equal to 0. If equation is in this form, then integrating factor is mx minus ny, right? So see here, it is not in the given form because okay, if we take out y from here, okay, if I take out y from here, I'll write it outside of the bracket now, y dx, okay fine, then it would be y cube plus 2. Okay, y cube is alone, there is no x cube with this, therefore this is not in this form, fine. So second rule is also not applicable. Let us try to look at the rule 3 or rule 4. Okay, for that we will have to find out difference between curly m by curly. For rule number 3 we will have to find out difference between curly m by curly y minus curly n by curly x, then we're gonna divide it by m. Okay, sorry n. Okay, for rule number 3, so it would be equal to कितना हो जाएगा ये 4y cube plus 2 minus y cube minus 4, which is equal to 4y cube plus 2 minus y cube plus 4, which is equal to 3y cube plus 6. Okay, now let us divide this difference by n. Okay, so it gives what is n here, n is equal to, okay, let me write it here, 3y cube plus 6 divided by n is so n is x y cube plus 2y square minus 4x. So see, this is not function of x only. Okay, therefore rule 3 is also not applicable here. Okay, rule 3 cannot be applied here. So let us check for the rule number 4 now. In order to check whether rule number 4 is applicable here, we need to find out difference between Okay, let me erase this because this is not applicable. Rule 3 is not applicable here. So let us try to look at rule number 4. Now calculate the difference. Okay, in this for rule number 4 we are going to take curly n by curly x first, or you can do one thing, you can divide it by negative of the m. Okay, if you are taking the same difference, curly m by curly y over m. Okay, let us see what is equal, it is equal to what, right? So you see y cube minus 4 minus 4y cube minus 2 upon m is equal to y4 plus 2y. It is equal to minus 3y cube minus 6 over y common, y cube plus 2, and 3 common from the numerator, y cube plus 2 upon. So see, from here it is clear that rule number 4 can be applied here, because all this is function of y alone. Okay, this is function of y alone. Therefore it is pretty easy to see that rule 4 is applicable here. y3 plus 2 cancel, and it is equal to minus 3 over y, which is your fy, right? So now since this is function of y alone, you can write it here, which is function of y alone. Okay, therefore integrating factor is equal to exponential of minus 3 over y dy. It is equal to exponential minus 3 log y. Okay, you can write it exponential log y minus 3. Okay, so log exponential cancel, so it is equal to y minus 3, which is equal to 1 over y cube. Okay, so therefore integrating factor in this case is equal to 1 over y cube, right? So now actually it is mod of 1 over y cube, so therefore uh, integrating factor could be 1 over y cube, also minus 1 over y cube. So now multiplying by 1 by cube throughout the equation, given equation, we get, okay, which equation? First equation, right? So give this equation number 1. Okay, so you can write throughout the equation 1, we get, okay, we get what we get? y4, okay, 1 over y cube, y4 plus 2y dx plus, okay, multiplication throughout, into x y cube plus 2y4 minus 4x dy equal to 0. So now some simplification, okay. So it becomes y plus 2 over y square dx plus x plus 2 over y, oh sorry, 2 into y, right, 2 into y minus 4x over y cube into dy equal to 0. Therefore, which is exact now? Which is exact, okay. Therefore solution is mdx integration being run over y is equal to constant plus all those terms of n which do not contain x equal to constant of integration, okay. Or rewriting this here, m is equal to y plus 2 over y square dx plus, so see this is your n, this term is containing x, so we will be not including this, okay. This is this term is containing not containing x, so we will be including this 2y, again third term contain x again, so we would be not containing we would be not including this, equal to constant of integration. So now integrating we get xy plus 2x over y square plus y square over 2 to cancel equal to c. This is the solution of given differential equation. Fine. So one more example now. Problem 2. Solve x plus 2y cube into dy over dx equal to y, okay. So this is given equation, I'm writing it equation number 1, okay. Rewriting this, okay, let me rewrite this, then we are going to give it equation number 1. Rewriting, it could be written as, okay, x plus 2y cube dy equal to y dx. Now take it to the another side, it is 0 is equal to y dx minus x plus 2y cube dy, or we can write it as y dx minus x plus 2y cube dy is equal to 0. So here give this equation number 1, here m is equal to y and n is equal to minus x plus 2y cube. Now curly over curly y is equal to 1, right, and curly n over curly x is equal to, it would be equal to minus 1. Therefore curly m by curly x is not equal to curly n by curly x. Thus equation is not exact not exact. So we need to find out some integrating factor in order to make it exact. So see, firstly, rule number one cannot be applied here, right? Because this term is containing degree 3 term and this is degree 1 term. Okay, so this function is not homogeneous, thus rule number possibility of applicable of rule number 1 is ruled out. Now rule number 2, again you see, if I take, so x, there is, I cannot take x common, so if it had been x over here, then we could have thought about this, but there is no x, so rule number possibility of rule number 3 is rule number 2 is also ruled out, right? So now let us check about rule 3. For this we need to find out difference of curly m by curly n. Okay, it is equal to 1 minus 1 upon n, right? So n here is minus x plus 2y cube, so it is equal to 2 by minus x plus 2y cube. Now this is not only function of x, so it is not only function of x, but it is also function of y. It is function of x as well as y, but if we would have gotten here function of x only, then we could have applied rule number 3, but again we won't be able to apply it here, right? So now let us check about rule 4. Find difference between this and this. Okay, so it is minus 1 divided by m is equal to y. So yes, this is function of y only. In this case it should have been function of x only, but in this case function, it should have been function of y only. So yes, it is function of y only, so we can apply this rule, right? So here now you write it, now curly n by curly x minus curly m by curly y over m is equal to minus 2 over y, which is function of y only. Therefore integrating factor is equal to exponential minus 2 by dy, right, which is equal to exponential minus 2 log y. Okay, which is equal to exponential log of y raised to power minus 2, log exponential cancel, so it is 1 over, or you write it first, y raised to power minus 2, which is equal to 1 over y square. Actually it has been it should have been written in the mod, so I'm just writing it directly because both can be integrating factor here, right? 1 by y square also and 1 by minus 1 over y square also. Okay, so therefore 1 by y square is integrating factor, thus multiplying 2 out by 1 by y square and solving, you will get the solution. I'm just leaving it to you to find out its solution, because we have discussed too much problem on this sort of equations. Okay, I hope you will do it. Okay, now let's talk about rule 5. Okay, rule 5 says, if equation in the form of, okay, if equation is in this form, x a y b mx my dx plus nx dy plus x a dash y b dash m dash y dx plus n dash x dy equal to 0. Then integrating factor is, in this case, integrating factor is x raised to power h y raised to power k. What are h and k here? So see, what are h and k here? These are the number which satisfy this property. Okay, a plus h plus 1 upon m is equal to b plus k plus 1 divided by n, and a dash plus h plus 1 divided by m dash is equal to b dash k plus 1 divided by n dash. Okay, let us take one problem on this also. Solve solve 2x square y square plus y dx. Okay, this is y dx minus x cube y minus 3x dy is equal to 0. So how you are going to solve this problem? Firstly, you will write here what is m, what is n, and then you will check two derivatives. Then you will come to know that both the that two derivative would not be equal to each other. Thus you will be able to say that this equation is not exact. Now in order to make it exact, you will be finding out some integrating factor. Okay, then you will be checking rule number 1. So rule number 1 would be not applicable here because this is non-homogeneous equation. Secondly, rule number 2 is also not applicable because you are not encountering with x and y together. Okay, there is some terms like this. If you see here, okay, sorry, this term, okay, the x cube is with y. So if it had been the case x cube is with y cube, then it would be fine. We could have think about rule number 3, rule number 2, but this is not the case. Also you will be checking out the difference between two derivatives. Okay, and you would be dividing them by m and n. Again you won't be able to find out function of x only or function of y only. So thus possibility of all 4 rules will be cancelled out here. Now we will be thinking about what about rule number 5, right? So in order to make it possible that rule number 5 is applicable here, firstly we are going to write this equation in this form. Okay, let us see, can we write this equation in the form which I wrote above? Okay, so see here, let me take this common. I can take common here. Oh, firstly, okay, let me rewrite it. 2x square y square dx plus y dx minus x cube y dy plus 3x dy equal to 0. Now this term and this term, okay, from this term and this term I'm taking x square and y common. Okay, x square and y I'm taking common from here. Whatever is left inside, see, x square has been taken common from here and y also has been taken common from here. So I'm left with 2 and y dx. See, here also, here y has been taken common and x square is taken common. So what we are left with is minus x dy. Fine. And whatever the left out term, these are y dx plus 3x dy. Now you can compare this with the form we are given in the rule number 5. Okay, this form. So see here, what is, instead of xa we are having x square, and in place of this yb we are having y, और m की जगह क्या है 2 है, y की जगह y dx, and in place of n we are having -1, x है वहाँ पे, dy है, plus then x raised to power 0 you can consider it, because x raised to power 0 is equal to x raised to power 0 is 1, so y raised to power 0, again you think about this. Okay, this is x raised to power 0, you think in your mind which is equal to 1, right? So again you see m dash is equal to 1, then y dx plus, okay, and n dash is equal to 3. So you write comparing with okay, let me write it again, comparing with xy by my dx plus ny dx, okay, dy up to so on. Okay, I have written it all already, so you just need to paste it from there to here. Okay, so see here, what is a, here a is equal to 2 and b is equal to 1, m is equal to 2 and n is equal to -1, right? Also you see a dash, and you see a dash here is, let me take you back. So see, this is a dash, right? So here is nothing but 1. Okay, so this is 1 here, right? So 1 can be written as x raised to a 0, y raised to a 0. So a dash is equal to 0, b dash is equal to 0, and m is equal to 1, m dash is equal to 1, and n is equal to 3. Okay, so now we are going to find out integrating factor. So in this form of equation, integrating factor is equal to x raised to power h y raised to power k, such that a plus h plus 1 divided by m is equal to b plus k plus 1 divided by n, and a dash plus h plus 1 divided by m dash is equal to b dash plus k plus 1 divided by n dash, right? So a is equal to 2, h plus 1, m is equal to 2, okay, equal to b is equal to 1 plus k plus 1 divided by n is equal to -1. A dash is equal to 0, so h plus 1 divided by m dash is equal to 1, equal to b dash is equal to 0, k plus 1 divided by n dash is 3, n dash is 3, so it is 3 here, right? So we are going to solve this. So cross multiplication, it would become 3 plus h into -1 equal to 2 times k plus and this would become 3 into h plus k is equal to 1 into k plus 1. Okay, so multiplication and rearranging the terms, minus h is equal to 2k plus 4 and 3h plus 3, okay, this was 1 only, equal to k plus 1. Now you see minus h minus 2k is equal to 4 plus 3 7, and second equation would be 3h minus k is equal to 2, right? Or you can write these two equation as h plus 2k, okay, minus to the another side minus 7, then take it to the left hand side is equal to 0. Okay, h plus 2k plus 7 is equal to 0, and 3h minus k, okay, 1 second, let me write it in this way, because this would be pretty simple to make you understand. Okay, so keep it here only, minus 7 and 3hk minus 1 is equal to 2 here. Okay, as we know how to solve linear equations, system of linear equation, multiply it by 3, this would be 3, this would be 6, this would be 21. Now subtraction, this would be plus, this would be minus. Okay, so cancelling, we get 5, okay, 1 second, yes, 6 plus 7, 7k is equal to, it would be equal to, 1 second, okay, this was, if I take 3 to this side, this would be negative, so this would be negative here. Okay, this is equal to minus, and this is minus, so it would be plus, so it would be minus 19 here. This implies k is equal to minus 19 over 7. Similarly, you can find h, it would be coming out. Now replacing value of the k in any of these two equation, you will get h is equal to minus 11 by 7. So therefore integrating factor is equal to x raised to power minus 11 by 7 and y raised to power 19 by 7. Okay, so now multiply both sides of 1 by x raised to power 11 by 7, y raised to power 19 by 7. Okay, so after multiplication you get, okay, what was our equation number 1? We are going to multiply this equation. Okay, this equation, I'm calling this A, this equation, okay, A, by this. So we get x raised to power minus 11 by 7, y raised to power minus 19 by 7 into 2x square y square plus y dx minus x cube y minus 3 dy equal to 0. After multiplication, you take it inside and you will get this and this multiplication, x raised to power 2 x raised to power 11 by 7 plus 2, it is equal to 3 upon 7. Okay, similarly 2 plus minus 19 by 7, it would be minus 5 upon 2. So it is minus 5 upon 7 plus, similarly it would be x minus 7 upon minus 11 upon 7, and y would be minus 12 upon 7 into dx. Okay, plus, okay, sorry, it is minus x raised to power, it would be 10 over 7, and this would be y minus 12 over 7 minus 3 into x raised to power minus 4 by 7 and y raised to power minus 19 by 7 into dy equal to 0, which is exact, and solution would be given by solution is mdx. Here mdx is, m is this, solution is 2x 3 by 7 y raised to power minus 5 by 7 plus x raised to power this and y raised to power 12 by 7 into dx. Okay, now you see this is your n, but there is no term in this n which do not contain x. Each and every term is containing x, though there would be no 0 here. Plus 0 is equal to constant of integration. Now integrate this and you will get the answer. Okay, so this was it for today. Rest of the things will be done tomorrow. Thank you.